Welcome to video 5.2e, another proof of parallel lines. This is example 4. I'll mark up the diagram as we go. So we've got AB being congruent to FC. We've got BC being congruent to DE. And we've got some right angles. Well, if perp, then right, I'll be able to say. And I want to get AD to be parallel to EF. Okay? All right, so right off the bat, and I already colored the triangles for you. I'm saying blue triangle and red triangle, and I'm going to try to get them congruent. And once I get them congruent, game over. I'll get this corresponding part congruent to this corresponding part, and then I'll have corresponding angles. Again, if I could get that angle and that angle, those are corresponding angles for those two lines. All right, so my goal is to get blue triangle congruent to red triangle, CPCTC, and I'm almost done. All right, so how can I do that? Ooh, I'm saying a side with a side, an angle with an angle. I could do a little bit of segment addition here, and I'll end up having SAS. All right, so I'm just going to write down SAS as my guidepost, and now I'm just going to make it happen. All right, so step one, I'll start with this. That's a freebie side right off the bat. So AB is congruent to FC, given. I get side credit. Then I'm going to go with these two things. That'll be if perp, then right. So AB is perpendicular to BE, and FC is perpendicular to BE given. Then I'll be able to get the right angles. Angle, I guess I could call it angle B. And angle, got to use three letters here, ECF, are right angles. If perp, then right angles. Then I'll get them congruent. Angle B is congruent to angle ECF. If right angles, then congruent. Okay, so then I've got the angle. Then I just need to get the third side. I'm going to do segment addition. Okay, so first I'm going to start with two segments that are congruent. So using this part of the given right here, BC is congruent to DE. That was given. And then again, I'm just going to do the segment addition. If a common segment is added to congruent segments, then those sums are congruent. So I'll say BD is congruent to EC, segment addition. Now I'll have the triangles by SAS, I'll get the parts, so I'll be good to go. So triangle, I'll call it BDA. I'm going to be wanting that angle. So triangle BDA is congruent to triangle CEF by SAS. Then I can get, this angle here congruent to that angle there. D is in the middle, and E is in the middle. So angle BDA is congruent to angle CEF by CPCTC. And now those are corresponding angles. They're both above the lines and to the right of the transversal. So AD is parallel to EF if corresponding angles congruent, then lines are parallel. And there you have it, another proof on parallel lines.